Thank you all for joining us. Let's go over something called lists today. So just going over the weekly schedule real quick. We're covering lists this week, even though it's supposed to be next week, to make up for President's Day. All right, so we finished 3, 4, and 5 already, right? These lessons a couple days ago. And we should have this done as well, Lab 5. So today we're gonna do a new topic on lists. This is a data structure. It's one of the first data structures we'll see in this class. It's pretty important to understand lists, fully understand it before we move on to the next ones. Everything kind of actually builds upon understanding, the previous stuff. Right? It's cumulative. Before we jump into lists, I figured we should probably have a sneak peek into the assignment, the week 2 project. So let's take a sneak peek at this. This second project is meant to apply variables and arithmetic. So let's go ahead and load it up. Last class, I already downloaded it into my server. I have it right here in the projects directory. And then I made another directory for a project, week 2. And there it is, using variables. Yeah, let's go ahead and load this up and kind of give a couple hints. Okay. The goal of this project is to write a program that calculates how many seconds there are in a solar year. And before we even, talk about this problem, let's kind of break it apart a tiny bit more. So don't read the stuff yet. I'm just gonna collapse it. Oh, okay, never mind, it doesn't collapse. Let's break it apart. If I were to ask folks how many seconds there are in a day, would you be able to calculate that? How many seconds in a day? Here, I'm just gonna block this out. This way folks aren't distracted by this. All right, how many hours in a day? I mean, how many seconds are in a day? Yeah. Someone said 3,600 times 24. Yeah, so that's another way of saying 24 times 60 times 60, right? So there are this many seconds in a day. Yeah, I hope that makes sense, folks. So for this many seconds in a day, because there's 24 hours, and there's 60 minutes in each of those hours, and then 60 seconds in each of these minutes. Now, I hope that makes sense. Right? We're breaking things apart. So if you can understand this arithmetic, then I think you should be able to get this project done. We want to calculate the amount of seconds in a solar year. A solar year consists of very specific time. Right? It's 365 days, but if we want to be more precise, right, a solar year also has an additional 5 hours. Oops, accidentally clicked into this markdown. Let me just run this so. And additionally, it has 48 minutes and another 45 seconds. Right, so that's the solar year. Would folks know how to look at these numbers and add them up, but into seconds? Right, but what should we do? Yeah. Yeah, that's definitely one way you can do it, right? We could convert all of these into seconds. Yeah, is that what you're doing? Converting? Yeah. So you can convert all of these into seconds, and then add them up. Yeah, we could totally do that. Let's do that approach actually then. And there are multiple ways we can calculate this. But yeah, I hope that makes sense. Right? We need to see how many seconds are there in 365 days, right, how many seconds there are in 5 hours, and then how many seconds in 48 minutes, and then add them all up. Right, add them all up. That'll tell us how many seconds there are in a solar year. Okay. There are some steps here in case folks aren't sure really how to think about it. You don't have to look at these series of algorithmic steps if you kind of already know how to solve it. So we kind of already talked about it already. You know, convert, add, right? That's really what this is saying right here. Okay, well, we could go with that. Let me open this cell. The notebook gives us a few variables that we can work with. The first cell here defines the stuff for the solar year, right? There's 365 in a solar year, so I'm just gonna run this cell. These variables will help us kind of make our equations look more readable. Our solution will be down here. The solution cell typically starts with this comment. Right? This is a multi-line comment with the 3 quotes right here. So I'm just going to put my name here real quick, Andrew Tack. This is our solution cell. All right. So I'm not exactly going to do the whole thing for folks. Maybe just give folks a head start so you can kind of see what's happening. Right? Maybe but once again, we want to calculate the total amount of seconds. Right? So we could do something. We could do something like maybe we could initialize a variable. Maybe I could initialize total equal to 0. Right? This is saying make a new variable called total and set equal to 0. Right? So we could initialize a variable to 0 and then accumulate all of the seconds, maybe step by step. Right? You don't have to do it step by step, but it'll kind of help us visualize the algorithmic thinking a little more. So let's do it step by step. We'll initialize total to 0, and we do need to accumulate something. Right? We need to accumulate one of these things. We need to accumulate all of these. Right? It doesn't matter which one you start with. Right? I guess I could start with days. Right? Just starting at the beginning. So let's convert the days to seconds and then accumulate into total. Right? So as someone in class said earlier, right? They said something about we want to accumulate the days, right, times 24 because there are 24 hours in each day, right? And then in each hour there's 60 minutes and then another 60 seconds within each of those minutes. And so this is saying, hey, total needs to become this now, right? But this isn't actually accumulating. Accumulating means we want to make total bigger and bigger, right? This is just setting it equal to it. Right? So you might have seen in the previous lessons that accumulating a variable typically means we're taking that old variable and then adding it to another thing. Right, let me just put this in parentheses. And here, let me comment it too so we can kind of see what's happening. So we are accumulate the seconds in 365 days. In 365 days. All right, so do people see what accumulation means? Hello? Hi. Okay, what's the next thing we should accumulate? Right, the hours. Our solar year has 5 hours. So let's go ahead and go accumulate it. All right, total, okay, is equal to what now? All right, we're taking the old value of total, right, and then adding oh yeah, we're adding hours. Right? How many seconds are in an hour? Right? We did that earlier. So we did something like there were 5 hours, and then in each hour there was 60 minutes, and then another 60 seconds within each of those. Right, and this is this is accumulating the seconds in 5 hours. That's what it's doing. Okay. We haven't really done any print statements. It's actually kind of a good practice to sanity check these variables along the way, right? So let's promote that good programming practice. Maybe I could do some print statements in between each accumulation, right? So we can make sure we're going okay. And so here I'm just going to do a print statement, say something like total is, and then I'll just put in total right here. I'll do another one. This is just sanity checking, by the way. So we will run this and press play. Okay. You will kind of see what's happening here. So the first, right, total initializes to 0. We accumulate the number of seconds in 365 days. Right, so the next step, total gets accumulated to this number right here. And then finally, we accumulate the number of seconds in 5 hours, right? So that's our next step right here. How's it going, Terrace? All right. So we just pretty much kind of did half of this project, right? Hopefully that kind of gives folks a head start on it. But yeah, the takeaway here, we are accumulating with this right here, right? Make sure you kind of fully understand why we are reusing total on the same line. Yeah, Enzo. Huh? Oh, we're not using lists in here. I don't think we're doing any mean. It's right here. Yeah. So if anything, this already defines. Oh, that is. Yeah. This is the average solar year. Yeah. So nothing with lists. Yeah. Good question, Enzo. Yeah. All right. But once again, make sure we fully understand this accumulation step. Right. Total is equal to total plus something. Right. In a lot of programming languages, typically the right hand of the equal sign is evaluated first. All right. So the thing we highlighted here, this gets evaluated first in the process, and then it gets stored into the left side. Right, so this becomes a number, and then it stores it into this total, right? It's overwriting it. And it's doing that over and over again, right? We're taking the old value, right, accumulating it, and then adding it to the original location. Okay, once we have the solution, right, this is not the full one. Once we have it, right, the end goal of this project is to print out a specific string. We want to print this out right here. Right, that's the total end goal. Just one print statement that says there are blank seconds in a solar year, right? And you'll fill in this blank with whatever your result turned out to be. Right, so this could be a total, right? So I'm just gonna copy and paste this right here. Okay, so these were debugging statements. I'm just gonna go ahead and comment them out because we don't really need them. Okay, let's say we finished it. Okay, we didn't, right? In this cell, we didn't. Just hypothetically, we finished. Right? Our end goal is to print a string that looks like this right here. There are exactly some amount of seconds, right? But in this case, we need to replace this with the actual number. Right? But we're not going to hard code it in. Right? We got to use the value of the variable. And in this case, we're using total. Does that make sense? We're not putting the actual number inside of it. We're using the result of this. Okay. Cool. Hope that folks get started. The very last cell in here, it might look complicated. This is really just an auto grader. Right? So you don't have to focus on this too much. If anything, I'm going to run this solution cell, but then run this auto grading cell right here. So let me just see what happens if I run it. All right, so it pretty much tells us whether or not we got it right. So there's kind of a few rubric items here, right? One is we need a docstring. This is just a comment at the top of the solution. And then check for a hard-coded number. Right? Hard-coded number means that we put the number in as a string when we shouldn't have. And then next, the program didn't print exactly what I expected. Yeah, that's because we didn't finish. But once you do finish the project, this should be a pass. Does that make sense, everyone? Okay. Okay, cool. All right. Any questions about this sneak peek into the week 2 project? Anybody on Zoom? All right. All right, let's jump into a new topic then. All right, I'm going to exit this notebook. Make sure you save it too. So I'm just going to save it. All right. Let's see. Let's go into lists. This is a totally new topic. It's going to be lesson number 6, and will be complemented with the lab on lists. All right, so I just opened up 2 things. All right, I opened up the lesson on lists and the lab on that. All right. This is one of the first data structures we'll see. Right, you can think of a data structure as a piece of your memory that holds data. Right? Lately, we've only talked about variables, which can hold one type of data at a time. Right? Like, what if we wanted to store a bunch of things, like a list right here? And for those of you who might have taken another programming language, other languages call this arrays, or they call it array lists. In Python, we call them lists, which is a way of storing multiple things. You can visualize it as maybe like a video game inventory. Right? Maybe for those who have played Minecraft, you can think of the hotbar as like a list, right? That's holding a bunch of items next to each other. So yeah, let's create a list. Right? The syntax for it, the minimal syntax for it generally goes with these 2 square brackets. So just use 2 square brackets right here. Right? This in Python means empty list. Right? So I'm just gonna assign it to a variable so we could kind of store it. Right? So this is saying create a variable called to-do list, but set it equal to an empty list. All right. We can store multiple things in here, right? Currently this is empty, right? If I were to print it, here, let me just print it real quick. So print, I'm just gonna say to-do list is, just to show it is empty. All right, see, it's empty so far. Well, we could populate it in the initialization if we want. Right? There's multiple ways we could do it. I'm just gonna populate it within this first line, right? Just like the example has it. So let's just say we have a list of 4 strings, right? So it's like storing 4 variables in it, but in this case we're storing 4 literals. Okay. Let's see. Okay, cool. So now our to-do list is right here, and we should be good right now. Right, just kind of this is initializing a list. Let me just comment it. Initialize a list with 4 items. All right, so we'll kind of see what lists are now. They're like, yeah, you can think about things next to each other. All right, before we move on, is everyone all good? Just want to make sure. Hey, are you all set up on your end? Oh, yeah, the good old Windows update. Okay, okay, cool. Just making sure everything's all good. Okay, let's move on. We can have lots of things in lists, right? We can have. Well, it depends on how much memory you have in your computer, actually, right? In this case, this to-do list has like this many things. It can be possible to maybe crash your computer if the list has too many things. But yeah, a list can have a many number of elements. So that's what we just did up here. Uh, and just to verify that it is a list, right? To do, I'm just gonna put it in this function. Last week we talked about a function called type, which is a function that tells us what category this input is. Right. Type is a list. Okay, let's move on a tiny bit more. Okay. I'm gonna skip over this. This isn't too important yet. This is called a conversion syntax. That basically we don't have to initialize it with 2 empty brackets. We can use this this thing right here, list. Right, this is the same thing as saying 2 square brackets. Okay. All right, let's talk about accessing list elements. Right, like what if it's what if we wanted to kind of display certain elements, right? Element, by the way, is a value, right? So in this case, element, this is an element, right? Sleep. Or if I were to ask, what is the element at index 2, right? The element at index 2 is program, right? So just to kind of do some bit of language. All right, if we were to access different list elements, there's a syntax again. It's using the same exact square brackets. Right, so if we were just to do a to-do list right here without any square brackets, right, this is going to give us the result of the previous one. But we can access certain elements at something called indices. Right? Indices is just a fancy way of saying number. Right, so if I were to access, let's see. But by the way, this is a very common pitfall right here. Right? What if I wanted to access the first element in a list? Right? This is a very common thing that people might do. Right? What's the first element? Right? It's not sleep. Right? Do people kind of see what's happening right here? Right? The first element is eat, but if I do like first, right, number 1, it gives us sleep, which is not true. 0, yeah. Someone in the Zoom chat says 0. Thank you, Joe. Yeah, so in a lot of programming languages, we typically start counting as 0. So there's eat right there. In most of the programming languages I've encountered, right, there are some exceptions. All right. So yeah, we can access multiple things, right? Like let's go 1, let's go 2, and 3. Cool. So there we go. We did all of them. All right. Let's just kind of see what happens if we exceed the bounds. Right. There are only 4 elements in this. Right. 0, 1, 2, 3. Let's see what happens if we exceed the bounds. I'm just gonna put in 4. Okay. We got an error, which makes sense, right? It says list index out of range. Maybe people see what that means. Right. The index here is 4. This is out of range because our list indexes are only 0, 1, 2, and 3. So this totally makes sense. Okay. Okay. Let's see. We just talked about the notation for accessing certain list elements, right? So we were only kind of using it to print stuff, right? Like if I were to go to do list 1, this is sleep, right? So this is just for printing things, right? That we can also change this element, right? Like let's say I were to take this element and just set it equal to something else. All right, so once again, uh, just to help visualize things, our to-do list. Whoops, I didn't mean to put that in. Let's just restart our list. Right, let's just restart, set it equal to these 4 elements again. All right, what's going to happen if we set the first element equal to this? All right, so I'm just going to write it right here. This is saying, hey, access the first element and then set it equal to wake up. Right, hopefully people kind of see what's going to happen. This is saying, hey, grab the first element, but then make it equal to this string right here. All right, so I'll run this and then print to-do list. So now we see that it's kind of modified, right? The first element, it was initialized to eat, but our second line modified it to wake up. All right, people cool with this stuff so far? Some good old lists. Okay, cool. Yeah, once again, this is just the foundation. Make sure we fully understand this data structure. Everything accumulates from here. If we don't fully understand lists, the things will get progressively harder. I think we have enough to get half of part 1 done in the lab. Let me look at the lab real quick. Oh, okay, it's a really short lab. Okay, cool. Let's see, part 1. Okay, you should be able to get number 1 done, 2, 3, 4. Okay, yeah, folks should be able to get half of part 1 done. There are 8 questions here. You should be able to get 1, 2, 3, and 4 done. All right, I just want to get folks hands-on, make sure they can, at least create a list. Yeah, so we don't know how to do 5, 6, 7, or 8 yet. But yeah, feel free to read ahead if you're still here. But yeah, we covered enough to do the first half. So yeah, let's take an intermission, like a 10 to 15 minute intermission. Make sure folks can do this. All right, I'm gonna give it 10 minutes and then pause the recording right here. Cool, welcome back from intermission, everybody. For folks who are on the recording, please try it before we go over the solutions. It'll help out with the problem solving process, and it'll also help you gain the ability to kind of do things and figure it out on your own a bit. Right? If you're just kind of waiting for the solution and then just copying it down, that kind of ruins the creative problem solving process. But anyways, on number 1, we want to create a list variable with these items. We did this in the previous lesson, but this one just has an additional element. Right, so we want to create another to-do list equal to something with 5 items. Right, so we're just going to initialize it to just 5 strings. Right, I'll fill these in just a bit. Right, so I just put 5 strings in here. We'll populate them right now. So wake up early, exercise, eat breakfast. Okay. And watch class. Okay, cool. Let's go ahead and print it out just to verify that we're all good. Okay, so I'm just going to print out something like a to-do list as a string, and then the value of the list here. And then run it. Oh yeah, which Wi-Fi? I would do secure HawkNet. Yeah, it's the fastest one. Yeah, yep. Secure HawkNet requires the Canvas credentials. Okay. We have a initialized list. Cool, so we're good. Now I verified it with this print statement. Right, this print statement is it's sanity checking. Okay, next one, we want to change an item, right, or change an element. Right? In this case, it's saying, hey, change the first element to another one. The first element is wake up early. So it's saying change this one to this one. Right? We saw this on the on the lesson right here, right? This was the last thing we did in the lesson. We modified the first element, right? So same exact thing. I'm just gonna go back in here, right? We want to modify the first element of the to-do list, right? So the first element was represented by the subscript 0, right? This is saying, hey, get the first element, and we're just gonna override it, right? We're gonna override it with a new string. Okay, so there we go. And then let's go ahead and print it just to make sure. Do lists. Okay, there we go. Looks like we're good now, right? The first one successfully overrode it because our print statement verifies that. All right, and be careful with notation. Right? Be careful. I think a common error might be folks might have put a square bracket right here. Right, this is not going to work out that well. What's actually going to happen if we use square brackets on this right? It's going to set the first element equal to a list of one item, right? That's not what we want. It's going to be like you're going to have a list within a list. We don't want that, right? We want the strings inside of the list. Right, so let's see what happens if I run this real quick. Right, see, we run this. Folks might see that the to-do list is nested now, right? The first element in the list is another list of only one element. So yeah, be careful with notation and make sure you sanity check things along the way. Right? In this case, just some common, just some frequent print statements. Okay, next one, print the third item in the to-do list. Right, so let's go ahead and print it. Right, to-do list, third item. There's a room for an off by one error. Right, an off by one error is if I put a 3 here. Right, is this the third item? No, 3 is not the third item. It seems like it, but once again, we start counting from 0. So 0, 1, 2. Right, 2 is actually the third item in the element. Right, so third in the list, I mean. So print. Okay, there we go. So that's the third element. Is your Wi-Fi all good now? Okay. Oh, good question. Yeah, what happens if we don't do print? Mhm, mhm. Yeah, that's a good question. The reason why we're printing is just to be more explicit. So if it weren't for the print statement, right, it does still show. But this is actually just a byproduct of a Jupyter Notebook. Yeah. Hmm. Yeah, exactly. And also just to kind of further reiterate that, right? Like, let me just do 0 right here. Right, so 0, this is wake up on time. But let's see what happens if I do another one, to do list, and then 2. Right, let's see, I'm going to run this cell. It only prints this last one. Right, so this is just a byproduct of Jupyter Notebooks. It'll show the result, the value of the last run statement. So that's why we printed it, just to be more explicit. Yeah, that was a really good question. Thanks for asking that, Terrace. Yeah, printing. Now we got both of them. Okay, good question. All right. Hold up. Let me pause the. Let me pause. Give me 1 minute. All right. Finally, this is the last one that we should be able to do, and then we'll get the others done in a bit. Right. Print the item at index 3. Right. Index 3. This is the fourth element. All right. So to do list. Fourth index 3. All right. So there we go. Print it. And there we go. Do Python lab. Right, this makes sense. The fourth element right here. 0, 1, 2, 3. Okay. We just finished the first half of the lab, right? 1, 2, 3, and 4. Let's go ahead and do the rest of the lesson on lists, and we should be able to get all of this done now. Okay, let's go back to the lesson. We left off at kind of accessing and changing elements. All right, let's talk about adding or removing elements now. Sometimes we want to change the size of the list by, adding things to it, or sometimes maybe we want to remove things. You can think of this as like a queue, right? So we don't have to think of it as a to-do list. Right? You can think of this data structure as storing like a line of people. Right? And let's say the first person is served, then you might want to delete that person. Right? Or let's say another person lines up, you might want to add to the list. Right? So we don't have to think of it as a to-do list. We can think very generally. Right? So sometimes we want to change the size of the list by adding or removing element. Okay, let's just start from scratch. I'm gonna say to-do list is equal to an empty thing, right? So this is saying, hey, take to-do list and just delete everything, right? Because now we reinitialized it to an empty list. Okay, so I'm just gonna start all over. Right? To-do list is empty. The equivalent to having things line up, right? Imagine there's an empty line, right? And then someone lines up, right? One way of kind of doing that with a list is by saying append, right? So we say to-do list.append. Append says it means to line them up in the back. So I'll append eat. Okay, let me just print it as well, just so folks can kind of visualize what's happening. So print to-do list. All right. So yeah, this is a class function, by the way. Right? A list has access to a class function called append, which takes an input. Right? It takes an input of whatever we want to put in. All right, let's append one more. And once again, append means to put them at the end of the line. So we're adding another thing. And then let's run it, see what it looks like. Run. There we go. See, sleep is now next in line. Okay, so we're really just increasing the size of our list. Okay. Yeah, yeah. More specifically, append goes to the end, so at the back of it, like the right. Yeah. It's possible to append to the front as well, like have someone cut in line, but we won't cover that function. I forgot what function it was called, but yeah, there is another one. Okay. Now let's add a couple more. To-do lists. Append. Program. Then repeat. All right, now there should be 4 things in line. Okay, there we go. Cool. All right. Yeah, so someone in the Zoom chat says, basically adding to the queue. Exactly. Yep, yep. If we were to think of it as people lining up in line, yep, append means to go at the end. But let's say someone wants to cut. Right? Let's say we want to give a functionality to have them cut in the middle of line. There is another function called insert. Right? This is a tiny bit different function. It's very similar to append. Right? But once again, if we want to cut in line, we do need to tell it where to cut. Right? Like, do they want to cut on the second in line? Do they want to cut on the third in line? Right? So that's a tiny bit different. Let's use this insert function. Right here, let's start over. Right? I'm just gonna reinitialize to-do list. I'm just gonna start over, reinitialize to-do list to just 2 elements. All right, got two elements here. Let me just print it out just to sanity check. All right, so we got two elements. Let's go ahead and play around with the cutting. All right, so there is a function called insert. All right, once again, it's a little different from append. Right? Append goes to the back of the line, insert goes in the middle of the line. But we need to define where is the middle. Right? So there are two inputs to this function. The first input represents where to cut. So let's just, I'm just gonna put 1 and then program. Right? 1 means we want to use the string and cut it to the 1th element. All right, so 0, 1, let's see what happens. All right, so this is, it cuts the 1th person. People kind of see what happened. So sleep, this is 0, and then this is 1. Right, but when we inserted program, yeah, exactly. Yeah, someone in Zoom chat says program is new 1 element. Exactly. Yeah, because program cuts in front of the person at the 1. Yep, exactly. Yeah, we're inserting it in front. Yeah. Yeah, good clarification. Okay, let's do one more. Let's go insert another one. Do list dot insert. Right. Let's go 0 this time. You know, 0 means that we're gonna push someone all the way to the front. So let's go eat. Right, we're gonna cut the 0th element, right? Replace them, and everyone will go backwards. So there we go. All right, pretty cool stuff, right? Good old lists. Yeah, this is very useful stuff. Yeah, that's one way. Yeah, yeah. There's multiple ways on kind of doing a lot of things with lists. As a matter of fact, we can actually just look up something. This is going to be very dense. It's going to be a kind of overload right here. So I'm going to go list methods Python. Let me just Google this. List methods. Okay, there are lots of things we can do with lists. All right, so far we covered something called append. Oh, by the way, I'm on the primary documentation. Right, this is the docs. You don't really have to know how to read this yet, but yeah, we covered append. Right, we covered insert. There's lots of other ways too, like yeah, there's just lots of functions we can use. So I'm gonna skip over it. Okay, let's talk about deleting and removing. Right, the opposite of increasing, and we should have enough to get the rest of the lab done. Let me just skim this real quick. Oh, okay. Okay, cool. Yeah, we got quite a bit more left to go actually. Delete, remove. Delete, remove. Okay, you know what? Let's cover a couple more things, and we can get the rest of the lab done, and then we'll jump back into the lesson. Right? So we're just gonna jump back and forth a bit today. I just want to make sure folks can do a bunch of hands-on and are on track. All right, so let's talk about deleting. Let's say our to-do list is initialized to these 4 elements right here. Right? Well, there's one way we can delete. This is not really a class function. It's more of a Python functionality. Right? Python allows us to use a keyword called del, short for delete, and we can just say delete to-do list at 2. This is saying delete this element right here. Right? 2 is the 3rd element, 0, 1, 2. And then we can just go and print it. Okay, eat, sleep, repeat. Yeah, we deleted this element right here. Now, once again, this is not a class function, right? Meaning that it's not a function that belongs to a list. Right? It's actually a native Python thing, the delete keyword. But let's talk about a class function now. Right, let's do it again, but the same exact way. I mean, a different way. Okay, so I'm just gonna reinitialize to-do list to this Same for elements. All right, let's use a class function. Right, a class function is a function that belongs to a list. All right, so I'm just going to go call the list and call the class function remove. Okay, and then type in work. All right, print do list. All right, so there's a bunch of ways to do the same exact thing. That's something you'll see in programming. All right, that's why there's a so diverse amount of solutions to a certain thing, certain problem. Okay, there we go. So we just did 2 different ways on removing things. This is a question off topic in the class. Which one do folks think is more efficient? Right, the first way we said, hey, delete the item at 2. Right, that's this one right here. But then the second way we said we use a class function dot remove work. This is outside of the scope of the class, but which one do folks think is more efficient? Yeah, I guess we could do that. You know, less typing with the first one, but not even in terms of typing. It's more like computation. Yeah. So here, I'm just gonna highlight it. This one, and then this one. Okay, someone in the Zoom chat, Joe. Let's see. But it looks for the string, and it doesn't matter which element it is. That is very related to the efficiency. Right, so we're asking which one is efficient, this one or this one? Right, the difference is the first one specifies the index to remove it at, but the second one specifies the element. So yeah, thanks, Joe. That's very related. The second one is less efficient. You might not see why, but we're in terms of computation, we're telling it to remove work, but this requires a search, right? There's going to be some computation in the background that says, hey, look for work, right? So the process will have to go, oh, is this work? No, it's not. Okay, is this work? No. Okay, is this work? Yes, it is. So then delete it. Right, so there's a tiny bit of overhead here, but this is very kind of inefficient if we have like a million things in the list. Right, it'll have to search through it. So yeah, the first one is more efficient. First one is more efficient because it doesn't require a search. It just goes there and deletes it. Goes to number 2. Okay, cool. Okay, well, one more and then let's finish the rest of the lab and then we'll jump back in again. All right, so we can delete the whole list, right? Like if we were to do something like here, I just initialize it. Let me print to-do list. So that's what a list looks like. There is a .clear function, which pretty much deletes everything, right? Brings us back to 0. 0 elements in there. Okay, let's jump back and forth a bit more. We just finished talking about adding and removing. We should have enough to get the rest of this lab 6 done. So let's do a little practice. We should be able to get 5, 6, 7, 8 done. After that, we will jump into some additional stuff in lists. Right? This additional stuff is going to be important stuff. But yeah, let's try to finish the rest of this lab. 5, 6, 7, and 8. I'm gonna give it like a 10-minute intermission. Cool, welcome back from intermission, everybody. Let's get the rest of this lab done. So 5, 6, 7, and 8 asks us to change the size of the list. Right, first one, we want to append sleep, right? Meaning to put at the end of the line. Right, to-do list.append sleep. Okay, there we go. It worked. Oh, by the way, there's a chance that people might be running a cell over and over again. For example, right here, I forgot to print it. right? I forgot to print it. So let's put the print statement here. Print to do list, right? So we printed it. Oh, but there's two sleeps here. Right? Oh yeah, yeah. It's okay. This is a byproduct of Jupyter Notebooks. The variable kind of stores things in its memory. So, oh yeah, that's what happened to you too, Joe. Yeah, there's a couple workarounds for this. Lots of them, right? One thing you can do is restart the kernel here, which means that you're going to restart the Python process. Everything resets. But if you do that, you have to kind of start over again, right? You have to go to the very top and run this, right? Another way is, um, see, if I keep running this cell, right, it gets bigger and bigger. Maybe we could just reinitialize it here, right? It's totally up to what folks want to do. In this case, I'm actually just going to restart everything. I'm just going to restart clear outputs of all cell in the kernel. Cool. So now I just got to start over again. So let me reinitialize, then run this again, run this. Multiple ways. I prefer restarting the kernel because it's closer to traditional programming, where when we run a program, it'll go from top to bottom, right, and then it'll finish the program, and then you can run it again. Oh yeah, kernel. Yeah, kernel is the Python. You can think of it as a Python process. It kind of stores the variables and all sorts of other info. Yeah, yeah, restart it and cleared output. It actually doesn't really matter. One of the first two would work though. Usually clear output, just to clean it up. Uh, mhm. Yeah, yeah, yeah. Hmm. Oh yeah, because it was just the order of running things. Yeah, like if you run this over and over again, it's gonna get bigger and bigger. Yeah, right. Yeah, it makes sense though, because to-do list um, gets bigger and bigger every time you run it. So you might want to. Yeah, yeah. So once again, folks, if you're accidentally running this over and over again, right, and sleep gets bigger and bigger, your to-do list gets bigger and bigger, you can just restart, right? So you can go to kernel and restart, or you can just run the very first cell again, right? The very first cell just reinitializes everything. Okay, there we go. Okay, insert. This is a function we use to cut in line. This one asks us to cut this one, right? Do Python lab. No, watch class. My bad. So let me just count this: 0, 1, 2, 3, 4. Right. So it wants us to insert something in the fourth index. So that's the to do insert. Right. The insert function is it takes two inputs. Right. The first input represents the number that we're cutting in. I believe it's 4. 0, 1, 2, 3, 4. And then the second input represents the element that we're inserting at that position. Okay, cool. Let's run this, and I'm just gonna not forget to print it. Print, whoops, print to-do list. There we go. And it should be cut now. All right. A couple more. These ones are for changing, it's for removing things from your list. We saw two different ways on removing things, right? One was kind of a Python native way. This is not a class function, right? If we wanted to remove wake up on time, we would have to kind of, with the delete operator, we'd have to kind of look at which index, right? In this case, is index 0. So you can do delete a to-do list, the 0th element. And let me just print it. This is just one way where we use the index. So there we go. We deleted the first element. And then the other way, this is a class function, right? Meaning it's a function that belongs to the list. To-do list.remove. Okay, we're removing sleep. When we use the remove function, it kind of does a search, right? Like, what are we searching for to delete? Right? In this case, it's a sleep. Right? So the differences are the first one, we use the index to kind of show what to delete, but then here in the class function, we have to kind of search for it. Like the algorithm inside will search for it for you. Print to-do list. All right. Yeah, good question, Joe. Yeah, yeah. This is case sensitive. Exactly. Yep. Just to further reiterate the case sensitive thing, it's kind of like if we do some Boolean operations again, like is sleep equal to sleep, right? So this is a once again it's a Boolean operator. At the equals equals, we're saying, hey, are these two equal? No, they're not. Right, but there are other things we can do too, right? Like maybe we could say dot lowercase think, and just lowercase both of them. Or you can probably do this right here. Oh, it's not lowercase. My bad. I forgot what string method it is, but if you look it up, there is a way to lowercase strings. Oh, good question. Now, someone just asked about the midterm, what format it is in. It is in a notebook format. Yeah. Oh, no, they're up there both in notebook formats. Yeah. Yeah, it should be chill. We have a practice midterm too, but we'll do that in like 6 more weeks. It's open book. Yeah. Yep, yep. Exactly. All right, let's move on to the rest of the lesson. So by now we should have the lab done. So feel free to save it, and then we'll submit it next week. Right, next week we're gonna do this dictionaries, another type of data structure. But yeah, you don't have to turn this lab in this week. This is for next week. All right. Uh, let's talk about some more additional things in lists. So far, all we really talked about was initializing a list, right? Creating it. We talked about accessing certain elements within using this index, right? This number. We talked about changing the size of the list, right? By adding or removing. But yeah, let's talk about some more things, right? There's so many things about lists we can do. Right? We're not going to cover all of it though. Just the surface level of it. There is a Boolean operation that we should be aware of, right? This is kind of like a Boolean operation that searches the list. So here, if I were to reinitialize the list to these 4 items, and just the Boolean operation is called a in, right? In is this is saying so a Boolean operation returns true or false. Right? So the result of this should be true or false. But basically, this is saying, hey, is eat inside of this list? Right? Well, we can find out. It is inside of it. Right? It is. So I'm just going to go ahead and find out. Right? So eat in to-do list. Right? I'm going to print it explicitly, actually. So print eat in to-do list. Right? Once again, this is going to tell us a Boolean value, right? True. Does that make sense? Because this is a Boolean operation, and it returns true because this is here. All right, let me try lowercase eat though. Lowercase is just saying, hey, is eat in here? False, because it's yeah, case sensitive. Okay. Let's go repeat. True. Yep, it's here. All right. Okay. This might get hard to read because the opposite, we can do opposites with a keyword called not, right? Not kind of just reverses thing. So if we were to say something like, maybe eat, let me go lowercase, eat not in to-do list. This might seem hard to read, but this is saying, hey, is lowercase eat not in to-do list? is it not in? It's a little hard to read at first. Is eat not lowercase eat? Here, let me just change it to something else. Let me go laundry. Is laundry not in it? Yeah, when folks take a discrete math class, there's going to be tons of things like this. Hopefully you thought that it was true, right? Laundry is not in it. Does that make sense? We can revert things. Okay. Just to kind of apply that a little more, I'm going to pull up the Python terminal again, just to kind of reinforce that not keyword. All right, is 1 equal to 1? True. Oh, whoops. Unexpected indent. Okay, is 1 equal to 1? True. All right, let me, I think you can go like this right here, not 1 equal 1. False. All right, because what's happening here, what two things? I think I need some parentheses to make it more readable. All right, see, so that's what's kind of happening. Right, we take this is true, and then not reverses it. All right, so people kind of see what's happening with this not keyword. Okay, cool. Lots of logic things we can do. The use of this booleans, we'll see later when we talk about decisions. We won't cover if statements yet, actually. We'll cover if statements, I believe, after the midterm. So if statements help us apply Boolean operations, right? Like if something is true, then do something, right? Else do something else. So that's why Boolean operations will be useful. We can make decisions and branch off to different parts of the program based off of some result. We'll do that later. Okay, couple more things we can do. Right, you might have seen the length function a while ago. Right, so we can also find the length of a list. Right, so in this case, I'm just going to copy and paste this. This is going to print out the length of to-do list. Okay, so it should be 4 things in here. There we go, 4 things, which makes sense. Right, by the way, this Python native function works with a lot of things. Right, in the very first week, we saw that it works with strings. Right, in the very first week, we saw like length of hello world, right, hello space world. The length is 11. Right, that makes sense. 5 plus 1 plus 5 is 11. Right, and now we just saw we can do a length of a list. Right, like I'm just gonna hard code a list in here, like hello, and then world. Right, so people can read this. We have a list of 2 strings, so the length of it is 2. Now we can do the length function with multiple things. This is a useful function for calculating the size of a certain data structure. We'll do more complicated data structures later. Now, people cool with the length function. Very, very, very nice stuff. Okay. A couple more fancy things that we can do. We're covering lists, some more list functions. All right, it is possible to convert a string. Right? Once again, a string is some text. It is possible to tokenize it. Right? Tokenize is a fancy way of saying split it up. It's something that happens with a lot of AI models now. Like when you're talking to like a Google Home, whatever phrase you're saying is typically tokenized and split up. So let's just say that we have a string here, and we're gonna split it, right? That there is a string function called split, right? This returns a list. Right? So it's going to return a list that should contain 5 elements. Right? So let's just see. I'm going to store it into something called words. Right? So words is a list. We can go ahead and print words. Right? Mary had a little lamb. So yeah, once again, this is a string function that returns a list. Right? And we just happen to store that list in something called words. Right? So this is very popular stuff right now. Right? Older AI models would split someone's phrase, and then it would kind of analyze each phrase. Right? Have people ever talked to like maybe a home assistant, like where you say, "Hey, turn on my living room light," or yeah, maybe you're trying to control your home. The primitive ones would, yeah, it would split it, right? It would split it and it would be like turn on, and then it would just analyze each element and kind of try to think about what you're doing. Okay. The opposite of split is join. So let's take the same exact, let's do the same exact thing, but backwards, right? We just split a string into a list. Let's turn a list into a string, right? Meaning we're going to take each element of it and just kind of combine them together. All right. Oh, you know what? We don't really have to do this first line because we already have words. We already have the words list as this. So you don't really have to copy this line. But yeah, if we were to do the opposite of this, right? Like we could say, hey, grab a space, right? So I just type in the space, and this is a string. It has access to a function called join, and we can go words. All right, so let me just store this into a sentence. Okay, so this is a little hard to read. It's basically a string function that takes a list as an input, goes through each of those elements, and combines them into another string. Right? If folks are, if this is hard to read, you can actually look at the documentation for this, which I'll pull up in just a bit. Right? So once again, this produces a sentence. Right? So all we did right here was take this list and join them with spaces. Right? So if folks want to look more into this, you can look up something called string methods, Python, and go to the primary source. I don't think AI models are primary sources, but this is a primary right here. Okay, so I'm just gonna go string methods, and let's see, string methods. Let's see, we were looking for join. So string dot join. It might be a little dense to read right now, but if you find yourself in a future Python class, primary documentation will be super useful. So yeah, join, it returns a string which concatenates all of the strings inside the iterable. Right? Iterable, fancy way of saying list. Okay. So yeah, you might find yourself reading that stuff. Okay. Finally, list errors. Oh, we already found this list error. All right, so we're gonna get a index out of bounds, and hopefully people have remembered this a tiny bit. Right, we have 4 items in this list. If we were to access something out of bounds, right, like to-do list, let me access maybe the 10th element, right? Oh, I mean, not 10th, the 11th element. should give us a index error, right? Yeah, we saw this a while ago. Right, so yeah, you'll see this a lot. Most likely, people will see it in off by one errors, right? That the most common one is, people would put 4 here to try to access the repeat, right? But once again, 4 doesn't access it. It's 3 because we start counting from 0. Okay. All right, so we just finished this whole lesson. Let's do some concluding thoughts and end class a little early today. Okay, going back to the weekly schedule, we have Monday off next week, by the way. Okay, so if we go to the schedule right here and click on next week, it is President's Day, meaning the campus is closed. I'm not going to be here, nor are any other faculty. So, looking at the weekly schedule, let's see, we are on week 2. We finished lessons 3, 4, 5, and also number 6. Right, 6. So we're kind of ahead, this was necessary, right? Just because we're missing President's Day. Um, but yeah, not yet. Yeah, right now there's only 2 assignments released. We got a RoboCat, and then we have the seconds in a year, which we talked about in the beginning of class. Um, but yeah, if anything, the most important things to do are probably the projects. But you should probably be doing the labs before the projects because it'll make more sense, right? So RoboCat, this is due on I think some day. I forget. Yeah, tomorrow at 5. So yeah, try to get that in. If you can't, it's fine. I'm pretty relaxed on the first couple of deadlines, but yeah, this deadline is here to let people know that you're falling behind if you don't have it in. So yeah, try to get it in. Okay, other than that, thank you all for coming, and hope you all have a great Tuesday, Wednesday.